Sorry. Just a second. Alright, so let's say that we have a vector A, and it looks something like this. I did this in lab recently. It's my vector A, and then let's say vector B looks something like this, my vector B, and then the sum of those two vectors will be the vector R. It'll start at A, end at B, so it'll look something like this. So that's it, R equals A plus B. We've done that graphically, and you could have some questions on your test, like upcoming tests in a couple weeks, 2 or 3 weeks, where you have to add up vectors graphically, just sketch them out, sort of show how they look. But you'll also have to add them up numerically, and we'll do that a lot actually in chapter 4 and on as we go out throughout the semester where we're adding up vectors, but primarily in chapter 4, where we want to know numerically what is the magnitude and the direction of the vector R. So if I have a vector R is equal to A plus B, the vector R is also going to be the sum of its components. That's to say that R will equal to Rx plus Ry. Right, we've already shown that's true. So if I sketch that out over here, I can drop down my R vector to the x-axis. And then that gives me the x component of R, so this is Rx. And then if I drop it over to the y-axis, this is my y component of R, or Ry. And then we can show that R is equal to the sum of those two vectors, right? So if I have Rx here, Ry here, then this is R. Rx, Ry, R. We can also show that the components of R are the sum of the components of A and B. That is to say that Rx is equal to AX plus BX. So if I draw AX up here, that is I drop this vector down to the x-axis. That's my vector AX. And then if I do the same for BX, drop this vector down to the y-axis. That's the x component of BX. Then Rx is equal to AX plus BX. Now with me on this, just graphically seeing how that works. Okay, so likewise we can say that Ry is equal to AY plus BY. There's BY right there. And then the same argument holds over here for the drop my y component of A. It looks like that. My y component of B looks like that. This is BY. This is AY. And so Ry is equal to AY plus BY. So these things are true. That the x components are the sum of the x components of the individual vectors, and the same for the y components. So let's do a quick example. I have a vector A that's 1 meter long and it's 45 degrees from the x-axis, and then vector B is 2 meters long and 60 degrees from the x-axis. So if I were to draw this, something like this, this is in quadrant 1. My first vector is 1 meter and 45 degrees, and then my second vector is measured 60 degrees, so it's something like this, and it's twice as long. Okay, so that's roughly what it looks like. My vector B is here, and my vector A is here. You should be able to sketch out vectors, given vectors like that, and then you can show that the sum of these two vectors will start here at A, and we'll go up there. So this would be the sum A plus B. That will help you when you just check your answers, when you sketch them out, just to make sure that they're in the right quadrant and all that jazz. So first we just want to find what is the magnitude and what is the direction of R. All right, so the course of this will be to find the x and y components of A and B first, and then you find your x and y components of R, and then once you find those, you can use your Pythagorean theorem and your tangent theta to find the angle for the vector R. So why don't y'all go ahead and find the x and y components of A and B. That is, what is AX, what is AY, what is BX, and what is BY. I'll give you just a couple minutes to find those. Remember, we had those expressions based on the cosine and sine functions for the x and the y components. While we're doing that, I'm going to go down a couple pages. I want to see something. Okay, yeah, there we go. I think I have this on the next page. The x component of 8 for me? What, 0.7? Yeah, I think that's right. Yeah, that's what I got as well. So it's 1 cosine of 45. 1 was the magnitude of the vector A, and that's 0.7 meters. And then what should be the y component of A? It should be the same, right? It's an equilateral right triangle, so it's also 0.7 meters because of this angle 45 degrees. And then over here for the x component, this is 2 cosine of 60. Of course, cosine of 60 is equal to what? What is cosine 60 equal to? It's 1/2, right? So this is a 30, 60, 90 triangle. It's useful just to sort of have a good feel for that triangle. I like to use it a lot. So this is 0.5 meters, or excuse me, 1 meter. 1/2 of 2, and then this is 2 sine of 60. Sine of 60 is like what, 0.86 or something? Yeah, so this is 1.7, call 1.7 meters. Alright, and then when you want to find, these are the x and y components of A and B, and then you want to add the components to find the x and y components of R, AX plus BX, AY plus BY. That's going to be 0.7 plus 1, and 0.7 plus 1.7, then you can find the magnitude. I'll let y'all do that on your own, and then also find the angle theta for that vector vector R. I'm going to sketch out what it looks like. Rx is here. Ry is bigger. This is going to be R. This will be my angle theta. Sleepy morning today. What's my magnitude, guys? Tom, do you have it? Tom? Do you have the magnitude? Right, so 2.9. Yeah, so we'll call it 2.9. So it's just Pythagorean Theorem, right? 1.7 squared plus 2.4 squared. And that's equal to 2.9. If we're talking about distances here, I don't think I have units on this, so we'll just say they're just 2.9 units. And then what's the angle? This angle right here? Okay, we'll just call it 55 degrees. So it's, hey Brittany, so it's 55 degrees. Remember to find that we say the tangent of theta goes opposite over adjacent. That's 2.4 over 1.7. So theta is the inverse tan of that. All right, make sure you're familiar with how your calculator works when doing those inverse trigonometric functions. It's be a little funky. All right, let's do some clicker questions. Actually, now while we're here, let's go ahead and introduce unit vectors. So in this class, a lot when we express vectors, we'll use unit vectors, and you'll use this in Calc 3 when you take Calc 3. Again, are there any students in Calc 3 this semester? You've taken it? Do you all use unit vector notation for vectors? A lot, yes. Okay, so we'll use it a lot in this class. A unit vector is simply a vector that denotes a direction in the x, y, or z direction. They have a magnitude equal to 1. So when I write them, they don't change the scalar quantity of the vector. They don't change the magnitude of the vector. They only give its direction. So you use these to write the x, the y, and the z components. So for example, if you have, and then we use, so for the x component, we use I. For the y component, we use j. And for the z component, we use k. And instead of putting an arrow over them, for reasons, I don't know, we just put a little hat over them. This is like the caret symbol or whatever. So we just put a little hat on top of them to denote that they're vector quantities. Again, they have a magnitude of what? They have a magnitude of 1. That means that they don't change the scalar value of the vector or the magnitude of the vector. They only give the direction, which is in the x, y, or z direction. So if I had a vector 10 meters to the right, 12 meters backwards, and 2 meters up, how would you represent the displacement in vector notation with ijk notation? Your x component is what? Plus or minus 10? Is plus 10. All right, so I'd say plus 10i. And then how would I write the other two parts? What is that? Okay, well actually this 12 meters backward, well it sort of depends. Yeah, we'll call this the y direction. Minus 12j plus 2 what? K. Alright, so this is our x, our y, and our z, and we'll denote vectors like that. When we get into cross products and dot products, it'll be important how we calculate those especially, okay? We can also talk about velocity and acceleration in terms of unit vectors. So, for example, we have v. We define that, remember, as dx dt in the I direction, plus dy dt in the j direction, plus dz dt in the k direction. So these are the velocities in all the different directions on the x, y, and z axes. These represent the magnitudes of the velocity, and then these are the directions, the x, y, and z directions. Or you could also write this just as Vx in the I plus Vy in the J plus Vz in the K. When we get into projectile motion next time, we'll use this quite a bit because we'll be talking about motion in these two dimensions, in the x and the y. All right. We can also, similarly, we can do this in acceleration. So we could say a is equal to axi plus ayj plus azk. Or you could also express them as dv dx. Tidy that up a little bit. the I, dot, dot, dot. Same for the J and the K. You can do the same for, do this for your average velocity and our average acceleration, but I'm not going to write it out here. But you can write them out in our vector notation as well. All right, let's do the clicker questions for this chapter. We haven't done, have we done these yet? No, we haven't. Okay, so let's do these, and remember these are good practice for the multiple choice part of your exam. They're in the back of your book. I don't know where exactly, but in the, I don't know the page number. Anybody have the page for that? So if you want to mark the answers back there, that's fine. $280. All right, so I have two vectors that are given such that the vector sum a plus b is equal to 0. What can you say about the magnitude and direction of the vectors a and b? So the vector sum of a plus b is equal to 0. Does everybody have their clicker today? Anybody not? Oh, we're still missing. There we go. Just a couple more seconds. Okay, very good. D. So they have to be opposite direction but equal magnitudes in order to add up to give 0. Very good. All right, given that the vector sum of a plus b equals c, and that the magnitudes add up such that the magnitude of a squared plus b squared equals c squared, how are the vectors a and b oriented? I'm doing pretty good on these. Just a few more seconds. I'll stop it. It's like 55. I'm going to stop it. Very good. That's right. That relationship is called what? A squared plus b squared. Right. Right. Pythagorean Theorem. And in order for Pythagorean Theorem to be correct, it has to be a right triangle. So vectors a and b have to be perpendicular to one another. Okay, let's try this one. First one's the vector sum. The second is the sum of the magnitudes, or the arithmetic sum. All right, stop at 50. Excellent. You are getting this all right. So they have to be parallel and in the same direction. That is, A has to be here, and B has to be here. So for their vector sum to have to be A plus B equals C, they have to be like this to give the vector C. But the same is true for their magnitudes to add up, to be A plus B equals C. Because if they were oriented in a different direction, like this, for example, if this was A and this was B, then this would be C. All right, you could still say that the vector sum A plus B equals C, but the sum of their magnitudes would not be a plus b equals c. Right? C would be something less than the c that we find right here. Yeah, get this okay? I seem to be getting it. You're good? My one-on-one class had trouble with this. If each component of a vector is doubled, what happens to the angle of that vector? Double the x and double the y, what happens to the angle? All right, so a few more seconds. Excellent. All right, so these, if you have these triangles, what are they called? If you have two triangles like that, like let's say that we have a triangle, they're called similar triangles, right? If I double both sides or increase both sides, these are called similar triangles, and the angles here are the same. Okay? Certain vector has x and y components equal in magnitude. Which of the following is a possible angle for this vector? My x and y components of this vector are exactly the same. They have the same length. So what is the direction of the angle for the vector? You can ask your neighbor if you like. Still, about 4 of you still have the answer wrong. So sort of chat amongst yourselves, get the right answers for everybody. All right, just a few more seconds. I'll take it away. 125. Okay, that's all right. So 45 degrees. It's an equilateral right triangle if they're the same length, right? And so this angle has to be 45 degrees. That's not the only possible angle for these vectors. What are some other possible angles for it that aren't listed here? 135, right? So if I can look in my other quadrants. So you have to be careful with your vectors. So this is a possible one at 45 degrees. This is a possible one at, what's this angle? What did you say, 135? Is that what you said, Chase? Yeah, 90 plus 45. And then you can also have in quadrants 3 and quadrant 4. 225, 3, 30. 315, right, yeah. So it can be in any of those. Now, this vector over here, for example, would have a negative x component and a positive y component. This vector down here would have negative x and y components, and this vector would have a negative x, or excuse me, this vector would have a positive x, negative y, and this would have negative x and negative y components. So on the multiple choice, you'll have a handful of questions just about basic vector stuff like this. If you're adding vectors of length 20 and 40 units, what's the only possible resultant magnitude? We had a question similar to this early in this chapter, last time I think. A few more seconds. Excellent. Y'all doing really well. 37. The minimum for this is 20 units. The maximum you can get is 60 units. So you can have them opposite directions, which will mean they'd be a 20 unit sum, or you can have them the same direction. So it's somewhere between 20 and 60, and so the only one of those is C, 37. And we'll get to this. We're going to do projectile motion next time. Alright, I want y'all to do this one on your own. So I want you to take the sum of, is this the right one? We've already done this one, haven't we? Is this the same? Sorry, I have another one right here. So I want y'all to do this one. Here I've given you a little table. I find it useful sometimes when I'm doing these just to make a little table like this. You might find the same. So given these vectors, here I have 3 vectors. I want you to find the x and y components of all the vectors, and then find the sum, a plus b plus c. So go ahead and first find the x and y components. You'll find they're nice round numbers. Just to remind you, y component or x component is a cosine of the angle. Y component is a sine of the angle. So the x and y component should still working? Another minute, okay. You read them off to me? What's AX? It's 1 AY, 2 BX, 3 BY. Okay, is it 4? It's minus 4. So be careful here. The reason we know it's minus 4, notice vector B. If I draw vector B, it looks like this. It's 5 meters at 53 degrees. So this angle would be 53.13. And so the y component would be on the negative y-axis. So that's not something you would get in your calculator unless you put in negative 53 for the angle, or 360 minus 53. All right, so it's negative 4. And then how about C? CX is what? It's negative 2. It's because this angle is above the negative x-axis, so vector C then is over here, and so the x component is negative. And then the y component is what? 5, right. All right, so those are our x and our y components, 1, 3, negative 2, 2, negative 4, and 5. And then I just want to add up those x and y components to find rx and ry. Remember, rx is ax plus bx plus cx. Ry is ay plus by plus cy. And then I'll leave you to find the Pythagorean Theorem, the magnitude and direction. So y'all go and do that. See, what's the x component? Rx? It's not 1. It's not 2. So unless I have a mistake. Oh yeah, it is 2. I'm sorry, I do have a mistake. It's going to be 1 plus 3 minus negative 2. That's equal to 2. And then what's the y component? What's the y component? It's 3, right? So it's 2 minus 4 plus 5 plus 3. And then do y'all have the magnitude? What is it? Okay, it's 3.6 meters. And then the angle is... Help me out here. I don't know what it is. What is it? Inverse tan of 3 over 2. Hunter, do you have this? What is it? 56.3. We had this? No? Okay, so 56.3, and that's going to be above the positive x-axis. All right? Oh, I do have it right there. Yeah, 56.3. All right, so, and then also if we want to do a difference of vectors, we can do a minus b minus c, for example, and then it's going to be about the same. Works out the same anyway. We take the magnitude of ax minus bx, which was 3, minus cx, which was negative 2. And then similarly here, we do 2 minus negative 4 minus 5. And so a minus b minus c gives me 0 and 1. That's going to have a magnitude with those components of what? Right, just 1. Square root of 0 squared plus 1 squared. And then the angle, of course, will be what? What is it? 90 degrees, right? So 90 degrees from the plus x. Okay? I think y'all have that pretty well. You want to do one more example? Yeah, Harley? Oh, because if I draw it out, I always have to draw these things out, but if I draw it out, my x component is 0, right? So there's no x component, and the y component is just 1, so there's no x component. That's how we know. If we weren't sure, I mean, you could always do the inverse tan of 1 over 0. Like if you're just having a brain fart and you just can't think about it, and then your calculator tells you 90 degrees. So if you're ever uncertain, you can just run the numbers. All right, I'll do one more example. Is that okay? I have a little clip. I can show you with multiple vectors. I know it's sort of a dead horse now, but it seems like y'all got this okay? Yeah. Just one question on the exam. I'll give you a handful of vectors, ask you to find the sum of those vectors. Hopefully it'll be an easy 10 points for you. All right, I have this this little animated short. This is a French film. It's about this little boy that gets invited to this little girl's birthday party, and he sort of goes reluctantly because, you know, he doesn't like girls because he's like 9 or whatever. And he, anyway, so along the way he goes into this adventure. But in the film they show this map, and that's really the only point of his route to the end. Right, so here's the route. He travels south for a distance, and he travels east for a distance, travels south again, east again, and then north for a distance. And let's see, we can sketch out the vector diagram for this. So it might look something like this. I have minus 5 meters. I have it negative because I'm going south, and then about 4 times that, or say plus 20 meters. And that's positive because it's east. And I have minus 20 meters. Negative because it's south. And then plus 10 meters. And then plus 5 meters. Positive because it's north. Alright, so our resultant vector will look something like this. It'll start here, and I'll go in that direction. These are all on axis, so it's pretty simple. I can find my x and y components for each of these. For the first one, the x component is going to be what? The 5 meters south. It's going to be 0, thank you. And the y component will be negative 5. Right, so go ahead and fill in the x and y components for the other 5 vectors or 4 vectors. And then we'll just take the sum, and then we'll be about done. We'll just wrap up after this. Josh, can you read off the x components? Do you have them yet? 0, and then what? Plus 20? 0. Right. All right. And who wants to read off the y components for me? Michael, you have them? Not yet. Who has the y components? Shay, you have them? What you got? All right. Negative 20. Very good. So those are our x and our y components. Some of them are negative because they're in the south or southerly direction, and every one of them has one that's 0 because they're on the axis. So it's either on the x or y axis. I can take the sum of these, so I find that my x component is positive 30, and my y component is negative 20. If we go back to that sketch that we had, that looks about right. That means that my x component here is positive 30, and my y component, what did I say it was, negative 20. So it's in the negative direction. So that makes sense. It's always nice to sketch out your vectors, give you a good idea if you're doing it correctly or not. So those are our x and y components. We want to find the length of that vector, and then we also want to find that angle theta, right there. And so we do that with the Pythagorean Theorem. We'll call that vector r is equal to the square root of 30 squared plus negative 20 squared. Of course, the negative 20, when you square it, the negative goes away, and I get 36 meters. All right, and then our angle theta is the inverse tan of our y over our x. It's 20 over 30. I get 34 degrees. But I have to qualify this. Now, usually, if you put this in your calculator, you'll also get 34 degrees. If you put it in with the y component as negative, as it is right here, you need to make sure that you get the right answer. So you might just want to try it in your calculator, because sometimes your calculator will get that negative mixed up. Like if you put in the inverse tan of negative 2/3, it doesn't know if this is negative or if this is negative. So I usually don't put any signs in at all when I'm doing my trig functions. It's a good practice, I think, because your calculator may do funny things with it. But it's 34 degrees, and then you want to qualify it as below the positive x-axis. And I know that because of the way I drew it on the figure before. And also I have this negative y component up here, which puts it in that fourth quadrant. All right. Probably a little bit too long on vectors, but I want to make sure that y'all have vectors, because vectors come up in chapter 4, and chapter 4, if you got vectors, then it's going to be pretty straightforward. Okay? So, y'all feel okay with them? Yeah. All right, guys. Well, next time, I'm going to let y'all out a few minutes early. Gosh, 10 minutes early. Yeah, I've already said. So we'll cut it loose now, and we'll pick up with projectile motion next time, okay? I'll be sending an email out about extra credit soon, today or tomorrow probably. And guys, I'm going to send out an option for extra credit, but you'll have additional opportunities as the semester goes on. So if this option doesn't fit well with you, then you can do something else later. See you, Cole. Hey, Brittany. Huh? Oh, yeah, what did we just try? Oh, we just started vectors. Yeah. What we did today was a lot of what we've done. Right, yeah. The screencast dropped, so you can take a look at that. But, yeah, unfortunately, yeah, then you can bounce back. Alright. Yeah, we went over the grades. Yeah, that's fine. Let's see, Corey, I have yours as well. Your exam. Oh, Corey's gone. Let's see. Pretty well in multiple choice. Oh, wait, no. Let's look at your freer skills. Here's just a That's supposed to be really simple, and it's just go to 2 seconds. That's one way you could have done it. Yeah, because it says it goes up and then it returns to its original position. So this is where it's at right here, and then it returns to this at 2 seconds. So that's it. I mean, you could have gone through a more long drawn-out process, but I took that. I just got it on the spot. Let's see. This one right here. Oh, really?
Yeah, because like they're doing the problems.
Looks like you missed. Actually, let me make sure. I think it's good.